Hello, grade 8. Today, I will be discussing factoring the difference of two squares. So for our learning target, I can factor binomials that are difference of two squares. So before we go to factoring, let us first recall perfect square numbers. So recalling on how we are going to identify each of the numbers here or expressions, whether they are perfect square numbers or not. So let's have the first one. 64 is a perfect square number because if we multiply 8 by itself, the answer is 64. Next, x squared is also a perfect square number or expression because when we multiply x by itself, the answer is x squared. Next, m raised to 7 is not a perfect square expression because we cannot identify any expression that when we multiply by itself, we cannot have m raised to 7. Next one, 36a raised to 4 is also a perfect square number because 36, as we all know, we can have 36 if we multiply 6 by itself. And then for a raised to 4, if we're going to multiply a squared by itself. Lastly, we have 72 x raised to 8 is not a perfect square number, although we can have x raised to 8 as x raised to 4 times x raised to 4, but we cannot have 72 as a perfect square number because we cannot identify any number that when we multiply by itself, the answer is 72. So therefore, 72x raised to 8 is not a perfect square expression. Okay? So therefore, as we summarize all of this one, which is very important to our next lesson, please take note of the following. Perfect square constant is obtained by multiplying a whole number to itself. So I listed here some of the perfect square numbers starting from 1 squared up to 8 squared. So all of the numbers that when you multiply by itself, the product or that number is what we call a perfect square number. Next, for a perfect square variable, you just need to remember that every variable whose exponents are divisible by 2 can be considered as perfect square variable. Example, x raised to 4, m raised to 18, z raised to 100. As you can see, the exponents are all even or all divisible by 2. So therefore, these expressions are all perfect square. Now, we are ready to identify the factors of uh, difference of two squares. But before that, let us first identify difference of two squares. So what is difference of two squares? It is a binomial whose terms are perfect square and the operation between the two terms is subtraction. So please take note of the two important conditions that we should have for difference of two squares. Number one, perfect squares. At the same time, the operation should be subtraction. So its factors are the sum and difference of the square root of the numbers. So just like this one. So later, we'll be factoring it. Next. A polynomial is a difference of two squares. So I just modified the definition a while ago so that you can easily remember it. Number one, it should be a binomial. Number two, each term is a perfect square. So both of the terms should be a perfect square. That's why, for our recall, we identify whether the expression is a perfect square or not. And lastly, the operation involved should be subtraction. Okay. So first, before we factor, let us identify whether the given polynomials is a difference of two squares or not, because that is very important. So let's have the first one. A squared minus b squared. First condition, binomial, check. Second condition, both of the terms are perfect square, check. Because as you can see, their exponents are both divisible by 2. Next, and lastly, the operation should be subtraction. So therefore, all of the conditions satisfied. Therefore, this one is a difference of two squares. Next, we have 4m squared minus 25. So, both perfect squares, correct. Binomial, check. At the same time, the operation is subtraction. So therefore, this one is a difference of two squares. Lastly, we have 3x squared minus 16. This one is a binomial, so check. Second condition, both must be a perfect square. So in that condition, it did not satisfy because, as you can see, 3 is not a perfect square number. So therefore, if the second condition did not satisfy, then this one is not a difference of two squares. Okay, so we are done identifying whether this one is a difference of two squares or not. So therefore, now we are ready to factor difference of two squares. So here are the steps in factoring difference of two squares. So number one, always remember that the first thing to do is to check whether there is a common monomial factor. Second step, check whether it involves a difference of two squares, because we cannot factor using difference of two squares if the given expression is not a difference of two squares. Next, identify the square roots of the two terms. Okay, so if both of the terms are perfect square, definitely we can get its square roots. And lastly, write the factors as the product of the sum and difference of the answer in third step. Okay, so let us now have our first example. Okay, so we need to identify the factor of m squared minus n squared. Okay, number one, check whether there is a common monomial factor, and as you can see, none. Next, let's proceed. Is this one a difference of two squares? Both of the terms are perfect square. A binomial, check. Operation, subtraction, check. So therefore, we can now factor. Let's proceed to the third step. So get the square root of the first term. So in getting the square root of this one, just divide the exponent to the index. So again, when we say index, the index of square root is 2. So 2 divided by 2, the answer will just be 1. So therefore, the square root of m squared, that is m. Or just simply think of a number that when you multiply by itself, the answer is m squared, and that is m. Because m times m, the answer is m squared. Let's continue. After we get the square root of the first term, the next one is to get the square root of the second term. So that is the square root of n squared. The answer is n. And then lastly, we need to write these two factors as the product of sum and difference of two terms. So sum first, and then, so that will be m plus n, and then m minus n. So therefore, here's the product of sum and difference of two terms. So therefore, the factors of m squared minus n are m plus n and m minus n. So to check this one, just simply multiply these two binomials, and again, use FOIL method in checking, or any method that you want, as long as you can multiply these two expressions correctly. Next, let us proceed to our second example. So the same steps that we're going to follow. Check whether there is a common monomial factor, and here, none again. So next, check whether this one is a difference of two squares. 4x squared is a perfect square. Y squared is also a perfect square. So second condition, satisfied. Third condition, the operation is subtraction. So therefore, we can now proceed in factoring. Square root of 4x squared. So the square root of 4 will have 2. And then the square root of x squared, the answer is x. Next, the square root of y squared, the answer is y. And then after that, we're going to get the factor form by writing the product of sum and difference of these two terms. So that will be 2x plus y times 2x minus y. Okay, so can we interchange these two operations? Yes, as long as your answer is a product of sum and difference of these two terms. Next, let's proceed to our third example. Okay, is there a common factor? None. Is this one a difference of two squares? Now, let us check. Binomial, check. 4x squared and 25, both perfect square. Next, Subtraction? Good. Now, so let us proceed in factoring. So, the square root of 4x squared is this just the same with the one a while ago. So, it's just 2x. Next, the square root of 25 is 5 because 5 times 5, the answer is 25. So, after that, we're going to write these two terms as the product of sum and difference. So, that will be 2x plus 5 and 2x minus 5. Okay, let us now proceed to the fourth example. 36x squared minus 16y squared. So, first step is to check whether there is a common monomial factor. And as you can see, there is a common monomial factor when it comes to the constant terms. So, we have here 36 and 16. CMF, or the common monomial factor, is 4, or the greatest common factor of these two numbers is 4. So, therefore, before we proceed to difference of two squares, we need to factor this one by using common monomial factoring. Okay? So, again, as we get the factored form of this one, we're going to divide each of these terms by 4. So, we have here 36x squared divided by 4 will have 9x squared. And then 16y squared divided by 4 will have 4y squared. So, therefore, the factored form is, again, this one is your common monomial factor, and this one is the remaining factor. And if you want to check, just multiply 4 to each of the terms, so we'll have this one. Next, as you can see, 9x squared minus 4y squared is still a difference of two squares. So therefore, we must need to get the factor of these two terms because we cannot have this one as our final answer yet. If we can still factor the given expression, then we must factor it. So therefore, let's proceed. Getting the square root of these two terms. So the square root of 9x squared, we have 3x. And then the square root of 4y squared, we have 2y. And then the factored form will be the product of the sum and difference of two terms. But do not forget to write 4 because that is the common monomial factor. So as we getting the final answer, don't forget to write the common monomial factor first, and that is 4. And then the product of sum and difference of these two terms. So that will be 3x plus 2y times the quantity of 3x minus 2y. And this will be our final answer. So now let us proceed to the last example. Factor 16m raised to 5 minus 81m cubed. Is there a common factor? Looking at 16 and 81, we don't have anymore a common factor because their GCF is 1. But looking at m raised to 5, mn raised to 3, we have a common monomial factor, and that is m cubed. So we need to get the remaining factor by dividing these terms by m cubed. So we'll have now 16m raised to 5 divided by m cubed. The answer will be 16m squared. And then 81m cubed divided by m cubed. The answer is just 81. But we're not yet done. As you can see, 16m squared minus 81 is a difference of two squares. So we still need to factor this, okay? So getting the square root of 16m squared, we have 4m. And getting the square root of 81, we have 9. So therefore, the final answer or the factored form of the given expression should be written like this. Okay, so write again first the common factor and then the product of sum and difference of the two terms. So that will be 4m plus 9 times the quantity of 4m minus 9. Thank you so much for watching. If you have questions, just message Miss Ria and Sir Alex. Thank you so much. I hope you learned a lot. And then after watching this video, please check your account in Kuiper for your seat work. Thank you.